Right, okay, guys. Session number 10. We're carrying on with sketching graphs in this session. Session 9 was looking at quadratics, and in this session, we're going to look at sketching cubics and reciprocals. Especially for cubics, it's a very, very similar process, so it shouldn't be much of an advancement. And reciprocals, you just sort of really need to recognize what's going on with those. Okay, right, cracking straight on. Okay, so sketching cubics and reciprocals. I'm going to start with cubics. Okay, so starting with cubics. Now a cubic's in this form, so y equals ax cubed plus something x squared plus something x plus something else. Okay, you've just got an x to the power of 3 term. Now if a is positive, the graph will form a shape like this. Okay. So you need to recognise that. If a is negative, it will form a shape in that direction. Okay, so it's that sort of shape. So that's a key fact to know for cubics. I'm going to go straight in with an example. So EG1, sketch. Let's go for x plus 2, y equals x plus 2 squared divided by x minus 1. Okay, now for the examples you see today and the questions, it will already be factorised for you. At A level, will you go into to look at how you do factorise cubics from scratch, but for these ones, they're already written in this form. You know this is a cubic because you're going to end up with an x cubed term, because you're going to have an x squared term there times by x. It's going to be a cubic. Okay, so up here, we could have written this. Cubic can also be written like something like x plus a, x plus b, x plus c. In that sort of, that's also a cubic. Okay. This form is it's the best form we want. We do not expand the brackets. Okay. If it gives us to it in factorised form, don't make it hard for yourself. But what we do is we follow exactly the same process we did for quadratics earlier. So step 1, we identify the shape. Now the shape, are you going to get a positive x cubed term? Now you will here, because you're going to go an x, it's going to be 1x cubed. So you know the shape is positive. So you know it's going to look like that. Okay. Step 2, y-intercept. And the y-intercept, remember this is when x equals 0. So when x equals 0, y equals 0 plus 2 squared multiplied by 0 minus 1, which is going to be 4 times minus 1, minus 4. I know the y-intercept is going to be minus 4. Step 3 is going to be the x-intercept. Now the x-intercept, remember this is when y equals 0. So 0 equals x plus 2 squared x minus 1. Now it's already factorised, so either x plus 2 squared equals 0 or x minus 1, 0. Over on this side, I'm definitely going to get one of my answers is 1. Over on this side, if I square root both sides, I'm going to end up with x plus 2 equals square root of 0 is just 0. So x equals negative 2. Now this one here is repeated because, again, the other way I could have done this is I could have said, well, okay, well that's the same as x plus 2 equals 0. So x equals minus 2 or a minus 2. So there's a repeated root here, which we'll see when that's useful when we sketch. Now, don't worry about the turning point for cubics. Again, you'll probably find that you'll do that at A level. But for this stage, we're just interested in the intercepts. So I can go ahead and draw this now straight away. So, draw the axes in. Y, x. I know it crosses my y-axis at negative 4. I'm going to put 0, negative 4 there. And I know it crosses my x-axis at 1, 1, 0, and negative 2. Again, it doesn't have to be to scale. Just get it roughly right. Now, because this is a repeated, this means it turns out to be that is a turning point. Okay, any repeated is a turning point. Remember the shape was this. I've got to draw this in a way that this effectively bounces. The repeated root bounces off axis. And the only way I can do that is if it just touches it here. So it's just going to touch there. It's not going to pass through. It never passes through a repeated root. It's going to go through there, and it's going to go up through that one. Okay, so that's how you would draw a cubic. Just be careful that it bounces off any repeated roots there. Okay, right. I'm going to do another example, e.g. to another cubic example. So y equals x minus 2, 3 minus x, and plus x. Okay, follow exactly the same process. Now, the shape. So step 1, the shape. Now, if I multiplied all this out, just multiplying the x terms, I'm going to get x times minus x times x. So that's going to give me a negative x cubed. So my shape this time is going to be that way around. Okay. Y-intercept, well, when x equals 0, y is going to equal, okay, minus 2 times 3, minus 6 times 1, minus 6. And then the x-intercepts, I'm going to go through this a bit quicker, but when y is 0, well, x is clearly going to be 2 for that one, 3 for that one, or negative 1 there. Okay, and now I can go ahead and sketch this now. There's no repeated roots, so I don't need to worry about anything bouncing. So I've got a 2, 0, got a 3, 0 there, got a negative 1 there, and then it goes through minus 6. Again, let's just label my axes to be precise. And remember, it's this shape here. There's only one way I can ever draw these. So it's going to go through there, bounce up and down. And there we go. Okay. So there you go. That's how you draw sketch cubics. Now I'm going to move on to reciprocals. Now reciprocals are in this form. So y equals a over x. Something over x, okay? Now I'm going to go straight in with an example. So e.g. sketch y equals 4 over x. Now you need to recognise that the shape of these. Now, if you're dividing by x, x cannot equal 0, can it? X cannot equal 0 because you can't divide by 0. So what I've got here, then I have to put a dotted line here. This is called an asymptote. The graph will never touch when x equals 0. Just can't touch it. The other way, if I was to rearrange this equation to get x equals something, well, x equals, again, if I do a bit of side working, x is going to equal 4 over y. So that means y can't equal 0 either. Because I'd be dividing by y, and I can't divide by something that's 0. So I'm going to go another asymptote here. I'm going to just label these asymptotes. One is x. These are asymptotes are lines that the graph will never touch. So x equals 0, y equals 0. Those two, the graph's never going to touch. And in the shape of this graph, it's just going to simply look like that on that side, that on that side. Okay. As x gets smaller and smaller and smaller, it gets a bigger y value, but it will never touch y. And same when x gets really massive, this number's really big, y is going to get really small, but it's never quite going to get to 0. Okay. It doesn't matter what, this 4 value has no effect on the shape, no effect on. I say no effect. It does make it slightly, so if it was it could affect it in terms of how far away from the axes are, but in terms of a sketch, in fact, no effect on sketch, I'm going to say there. Okay, because it does have a slight effect on the shape. Let's just do a final example on reciprocals. So sketch. Let's go to a slightly different one. So y equals negative 5 over, say, something like x plus 2. Right, now what I'm going to do here is have a think about what x couldn't be. Now you can't divide by something that's 0. So x plus 2 cannot equal 0. So x cannot equal negative 2. Okay, that's going to be one of my asymptotes, negative 2. Now if I rearrange this equation, I get x plus 2 equal to minus 5 over y. Again, I can't divide by something equals to 0, so y cannot equal 0 either. Okay, that's where I get the asymptotes. So always start with the asymptotes. Y, x. I'm going to put the asymptotes on. So x cannot be minus 2. X is minus 2 is this line here. That's going to be my x asymptote. X equals minus 2. Y asymptote was the same. I'm going to draw that in there. And in the shape of the graph, this is negative this time, which is important. So it's not the same as before. In fact, it just flips it over. So you're going to get a situation that looks like this. Okay. And that would be my solution. Okay. I've labelled the graph. I could, if I wanted to, it doesn't ask me to put the intersection in there, but I could have done that by setting x equal to 0. And I can always check my answer. If I put a really big value of x in, I'm going to get a negative very small value of y. And I can sort of check the shape by putting in some practice values. Okay. Right, that's the session today. Again, the worksheet, please can you do all the questions now? The answers are there as well, but keep your notes nice and neat. Remember, sketches are only sketches. You don't need to draw them super accurately, but the bigger the better generally for sketching graphs. Okay, well done guys, and tune in for session 11 shortly.